In this lecture, we talk about quantum numbers. The first one that which we deal will be principal quantum number. It describes the electron shell or the energy level of an atom. The value ranges from 1, 2, 3, 4. This point to be noted. Now, generally we specify K, L, M, N. That means for this the N value is 1, for this is 2, this is 3, and this is 4, so forth and so on. The next quantum number that which we talk about is azimuthal quantum number. Please remember, it talks about the shape of an atomic orbital, which is very important and needs to be remembered. One more important thing, the values vary from 0 to n minus 1. That's why if you see, the value of n can never be equal to L. And if L is equal to 0, it is called S sub shell, L is equal to 1, P, L is equal to 2, D, L is equal to 3, F sub shell, so forth and so on. Now, the third quantum number that which we deal is magnetic quantum number. The magnetic quantum number describes the energy levels available within a subshell. Please remember, it talks about orbital orientation. Very important, it talks about orbital orientation in 3D space. In 3D space. Now, every m value specifies one orbital. This is very important part. If L is equal to 0, mathematically m can be 0, so only one value is feasible. If L is equal to 1, m is minus 1 to plus 1, 3 values are feasible, so it is 3 orbitals. If L is equal to 2, 5 orbitals. If you are getting confused, how did you end up with that? So please remember, if n is equal to x, L can be x minus 1, x minus 2 till 0. M will be minus L to plus L, S can be plus F or minus F. Please remember, every orbital can take 2 electrons. So please remember, one orbital will take 2 electrons, 3 orbitals will take 6 electrons, and 5 orbitals will take 10 electrons. This is a small technical problem, that's why it's not writing properly. Please remember 10 electrons. Now, we'll just talk about it in a moment, just a moment. Please remember, principal quantum number talks about energy level. Azimuthal quantum number talks about shape of an atomic orbital. And magnetic quantum number talks about orbital orientation in 3D space. Now, the last and the fourth quantum number talks about the spin of electron within the orbital. Please remember, the spin could be plus of or minus of. Plus of signifies clockwise spin and the minus of signifies anti-clockwise spin. Using these 4 quantum numbers, we can predict a few more things. That is the energy of the electron, which is if 4 electrons with different quantum numbers are given. So we can specify the energy and we can specify a few more things. Now, the next topic will be Aufbau principle. Please remember, Aufbau principle states that an electron occupies orbitals in order of lower energy to higher energy. Please remember, it is not a scientist's name or something. The Aufbau means German building up principle. Sometimes it is called building up principle. Please remember, generally we draw the Rangoli in the class 1s, 2s, 2p, 3s. You need to understand why we have done quantum numbers pehle is. If you see here, there is no 1p, there is no 2d, because look at this. To have p, L has to be 1. For L to be 1, minimum n has to be 2. That's why there is no 1p here. Hope you are understanding what I'm saying. To have a P, L has to be 1. For L to be 1, N has to be minimum 2. That's why P starts from 2. And same is with D. For D, L has to be 2. For L to be 2, N has to be minimum 3. That's why D starts from here. Now, you can do it in one more way, that is by adding the N plus L values, you can predict 1s, 2s, 2p, 3s, 3p, 4s, and 3d. Please remember S has one orbital, so it will take 2 electrons. L value 1, P will take 6 electrons, D will take 10, F will take 14. For example, if we have mentioned first 1s, 2s, 2p, 3s, 3p, 4s, and 3d. We have mentioned it in the order. We have added the N plus L values. If you see, they are in the increasing order of their N plus L. That means N plus L is proportional to energy. Now, if you see 2p and 3s and 3p and 4s, they have same N plus L value. If you have same N plus L value, lower N value will be filled first. That's why 2p and 3p they come first when compared with 3s and 4s. Now, here I have mentioned 2 plus 2 plus 2, that is 6, that is 10 electrons, 10 electrons, and 10 electrons. That means by the time we complete filling 3D, we would have reached zinc in periodic table. Above principle talks about filling of electrons, lower energy to higher energy. देखो बेटा, whenever you cross first floor से आगे जा रहे हो, तो you please remember that you will get second floor, whether you stop or whether you don't stop, whether you go in the lift or you go paidal, second floor आना ही आना. That's what is above principle, lower energy to higher energy. Now, we go to the next one. That is Hund's rule. Please remember, beta, it's सबसे तगड़ा rule है. Degenerate, that's what I have mentioned here. Degenerate, please read. Whenever you have orbitals of same energy, you put one electron each and then you start pairing them. For example, beta, please remember if L is equal to 1, that ML values will be -1 to +1. 3 boxes signify 3 orbitals and they have same energy, that's why they are in same line. थोड़ा गंदा representation है, गाली मत देना आप. And degenerate signifies, it's a technical term which is used to specify same energy. The 1, 2, 3, 4, 5, 6, they signify number of electrons. Now please remember the first electron will be represented like this. Please remember this signifies a spin plus. If it is P2, we signify it like this. P3, 3 single electrons, then 1, 2, 3 and 4. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5 and 6. Please remember, if you are calculating the spin of the species, इसका spin आएगा plus half, इसका spin आएगा 1 plus 1, इसका spin आएगा plus 1.5 और 3/2. इसका spin आएगा, please remember, this is minus half, so this will become 0. इसका spin आएगा plus 1. This has become 0 spin. Plus half plus minus half. जिसका spin होगा plus 0.5 और इसका spin होगा 0. So Hund's rule is very important rule. It says that whenever you are filling electrons into orbitals of same energy, we should put one electron each, then only we should start pairing. For example, if you are talking about, if let's say L is equal to 2, L is equal to T means M will become -2 to +2, there will be 5 values. That means there will be 5 orbitals. Please remember, we put 5 boxes. 1, 2, 3, 4 and 5. All are of same energy. थोड़ा गंदा drawing है. Please remember 5, if you are putting D में 5 electrons, because I've specified this signifies number of electrons. This will become 1, 2, 3, 4, 5. This spin will be plus 2.5. Please remember this. Whenever you are putting our electrons into orbitals of same energy, we should put 1 electron each. Now, the next rule that which we talk about is Pauli's exclusion principle. Please remember, this is called NLX representation, where the X talks about number of electrons, L obviously the azimuthal quantum number, and this guy principal quantum number. In Aufbau principle, we have seen that 1s comes first and it can take 2 electrons, though the helium's representation 2 electrons. So for helium, the representation will be 1s2. So there are 2 electrons. Please remember electron 1 and electron 2. If you see what Pauli's exclusion principle says is, no 2 electrons in an atom can have all set of same quantum numbers. This is very important. For example, if there are 2 electrons in an orbital, please remember the n value is same, the L value is same, the m value is same, but this is not same. Thing to be noted, understood and appreciated, that no 2 electrons in an atom can have all 4 quantum numbers same. That's why we use these quantum numbers to differentiate electrons or to predict the energy of the shell or the subshell or whatever it is. So please remember, these two are not same. So this arrangement follows Pauli's exclusion principle. Now, for example, if you are saying that hydrogen's first electron, the quantum number will be N, L, M, S. The quantum number will be 1, 0, 0 and plus. If you take helium's first electron, again the quantum numbers will be same. It is equal to 1, 0, 0 and plus half. But please remember, these two are different atoms. That means if you are talking about the electron which is present in different atoms of different atomic numbers, the quantum numbers of that will be same. For example, if you're talking about the first electron of any atom, the set of quantum numbers will be same. But no 2 electrons in an atom can have all 4 quantum numbers same. What do I mean by that? For example, if you're talking about electron in 2p, please remember n value will be 2, L value will be 1, m will be minus 1, 0, plus 1. S is equal to plus half or minus half. So, Pauli's exclusion principle helps us to differentiate the electrons in an orbit. Please remember, very important part, every m value signifies, I think we have specified it earlier. So let us go to that slide once again. Every m value specifies one orbital. This is very important. And one orbital can accommodate 2 electrons only. Now, hope you understood the significance of quantum numbers and their application. What we have done is, we have seen first principal quantum number, which is represented by n, which is represented by n. Please remember, this is represented by L, and this is next one, magnetic quantum number. It is represented by M or ML. It is represented by the next spin quantum number is represented by MS. Now, Aufbau principle. If you are talking about Aufbau principle, whenever you are filling electrons, you fill from lower energy to higher energy. If you are talking about Hund's rule, when you are filling electrons into orbitals of same energy, that is degenerate, all of them should get 1 electron each. And last but not the least, Pauli's exclusion principle. No two electrons in an atom can have all 4 quantum numbers same. Hope you understood quantum numbers, Aufbau, Hund's rule, and Pauli's exclusion principle.